Hi guys again, this is your channel Stat and Math Tutorials in another video. Today I will show you how to use StatCrunch to answer questions that related to geometric distribution. So let's start. So first, what is geometric distribution? So geometric distribution represents the number of failures before you get a success in a series of trials. So for example, if you toss a coin until you obtain head, the number of tails before the first head has a geometric distribution. And the requirements of geometric distribution are the same as the requirements of binomial distribution, which are 4. So the first requirement, you need to have a fixed number of trials. Second, trials must be independent. Third, trials have only 2 outcomes. And the fourth requirement, the probability of success or the probability of failing is the same for all trials. And let's mention what's the formula for the expected value for geometric distribution. So the expected value is 1 minus p over p, where p is the probability of success, and the variance of geometric distribution is 1 minus p over p squared, and again p is the probability of success. So now let's look at these two examples and see how StatCrunch can help us do some geometric distribution questions. So let's look at the first example here, and it says Mike plays a game until he loses. So suppose that the probability of losing is 0.52. So what is the probability that it takes 6 games until he loses? So this is geometric distribution. So the probability of losing is 0.52. So if you go to Stat and you go to Calculators and choose Geometric, let me move this up here. So we said we go to Calculators, Geometric distribution, and it's you have in StatCrunch you have 2 options: the number of failures and the number of trials. So both of them will give you the same answer, but you just have to understand what the definition, what's the difference between number of failures and number of trials. So the number of failures is the number of games until Mike loses, including the losing game. So in this case it's 6. But if you'd like to do it a number of trials, so the number of trials in all the failures plus the first success, so it's gonna be 7. So let's do it a number of failures. Let's move this here. So we have the probability of losing is 0.52, and it says 6 games before he loses. So it's equal sign here and 6 games, and compute. So it's 0.0635991. That's the probability that it takes 6 games before Mike will lose the game. So if you decide to do it on a number of trials, So you go again to Stat, Calculators, Geometrics, and number of tries. So same thing, number of success is 5.2 or 0.52 equals here, and it's not 6, it must be 7, because the number of trials is all the failures plus the first success. So it's gonna be 6 failures plus the first success, which is 7, and compute. Here you go, we get the same answer like before, 0.0063591. So this is just this is only the small difference between doing it using number of trials and using StatCrunch for geometric distribution using the number of failures. So just pay attention to these little or tiny things here. So let's look at the second example here. So you choose a fair die. The probability that 6 will appear is 1/6. So what is the probability that it takes 8 tosses until 6 appears? So same thing here. You do, let's do it just a number of failures. So calculators, geometric, number of failures. Let's move this up. So the probability of success 1/6, 1 divided by 6, and x equal 8, it's equal 8, and hit compute. So here you go, the probability. So the probability that takes 8 tosses until 6 appears will be 0.0387. And you can do standard like these two examples, or you can do also between. So for example, what's the probability will takes between I don't know, between 4 tosses and 6 tosses before you get 6. So you do 4 here, 6 here, and compute. So here you go, it's about 20% chance. So that's how you do StatCrunch to do geometric distributions. So I hope you enjoyed this video. Thanks for watching, and see you in the next video. Bye.